Hi students, this is Alex here. In this video, we are going to find the half-range Fourier cosine series for the given function f of x, which is x sin x in the interval 0, pi, and also we are going to prove this expression. Now, we are going to write the formula f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx. Now to find a naught, we use 2 by pi integral 0 to pi f of x dx, and f of x is x sin x, which we are going to replace it here. And after replacing, we are going to use Bernoulli's formula to integrate this. First term is u, second term is v. Let's take it separately. U equal to x and v equal to sin x. Now u dash is 1, u double dash becomes 0, and v1 is, its integration is minus cos x, and again further integration is minus sin x. Now Bernoulli's formula is u v1 minus u dash v2 plus u double dash v3 dot dot dot. So a naught becomes 2 by pi u, which is x, v1 is minus cos x, minus u dash is 1, v2 is minus sin x, and we have limit from 0 to pi. When I apply the upper limit, this is pi, cos pi is minus 1, already there is a minus, so it will become plus 1, sin pi is 0. When I apply the lower limit, because of this x it is 0, because of sin it is sin 0 is 0, so lower limit is totally 0. And even sin pi is 0, so we left with only this term. So 2 by pi into pi, after cancelling we left with 2. So a naught equal to 2. After getting a naught, let's find an. An by formula, it is 2 by pi integral 0 to pi f of x into cos nx dx. So this is 2 by pi integral 0 to pi x sin x. We replace f of x, then we have cos nx dx. Usually we write the n term as a first term, so we are going to rewrite this. That is 2 by pi integral 0 to pi x into cos nx into sin x. Then we have dx. We are going to apply the basic trigonometric formula. Whenever we have cos x into sin y, this is 1 by 2 sin sum of the angle nx plus x minus sin difference of the angle nx minus x. Let's write this in terms of x and y, then I apply for the term there. So it is sin of x plus y minus sin of x minus y. So sum of the angle and difference of the angle. So here this is x and this is y. So 2 by pi integral 0 to pi x bracket open half. Now we have sin of nx plus x minus sin of nx minus x, then dx. We can cancel this 2 and 2, and we can rewrite this 1 by pi integral 0 to pi x into sin of, we can take x common, so n plus 1x minus again x common, n minus 1x. Now we are going to apply Bernoulli's formula again. So the first term is u, which is x, and second term is v, which is sin n plus 1x minus sin n minus 1x. So u dash is 1, u double dash is 0. v1 will be its integration, so minus cos n plus 1x by n plus 1, minus or minus will become plus, so plus cos n minus 1x by n minus 1. Further integration, this is minus sin of n plus 1x by n plus 1 whole square, and this will become plus sin of n minus 1x by n minus 1 whole square. Now when we apply the Bernoulli's formula, an equal to, outside we have 1 by pi. So we write that 1 by pi. The formula is u v1. Let's write the formula here. U v1 minus u dash v2 plus u double dash v3 dot dot dot. So u v1, which is minus cos n plus 1x by n plus 1 plus cos n minus 1x by n minus 1 minus u dash, which is 1, into v2, which is minus sine of n plus 1x by n plus 1 whole square plus sine of n minus 1x by n minus 1 whole square. Then we have 0 to pi as our limit. Now let's substitute the upper limit. This will become pi into minus of cos n plus 1 pi is minus 1 whole power n plus 1 by n plus 1 plus minus 1 whole power n minus 1, if I substitute for the second term, by n minus 1. Then we have minus of sine n plus 1 pi, sine n minus 1 pi, all the terms will become 0. So totally this is 0. So we completed the upper limit. When you put the lower limit, since x is there, it is completely 0, and all the sine terms are there, so completely 0. So all the lower limit is 0. Now we can cancel this pi and pi, and minus 1 whole power n plus 1 by n plus 1 we have with a minus sign, and this is minus 1 whole power n minus 1 by n minus 1 we have. This we are going to split further, minus of minus 1 whole power n into minus 1 whole power 1 by n plus 1. Then again this is minus 1 whole power n by minus 1 whole power 1. Then we have n minus 1. So this minus and this minus we can cancel, and finally we left with minus 1 whole power n by n plus 1, and this minus sign we can keep it at the middle. So minus of minus 1 whole power n by n minus 1. Now minus 1 whole power n, when we take common, 1 by n plus 1 minus 1 by n minus 1. So this is our an. Now further we can take LCM. So minus 1 whole power n, when we take LCM, here it is n plus 1 into n minus 1. So this is n minus 1 minus n minus 1. So after cancelling this, we left with minus 1 which is minus 2. So minus 1 whole power n into 2 by n square minus 1. So this is our an, and further we can check the values if n is odd or even, or else we shall keep this as it is and substitute the formula. So we got an. Since we have denominator n square minus 1, when n is equal to 1, then this value will become undefined. So for this purpose I have to find separately a1. So a1 by formula 2 by pi integral 0 to pi f of x into cos nx, but now it is cos x alone dx. So since this value does not exist when n is 1, we are going to find a1 separately. And now replacing f of x, we have 2 by pi integral 0 to pi x sin x into cos x dx. Now we have a basic formula. 2 sin x cos x is sin 2x. So if I want this alone, it is sin 2x by 2. So we are going to replace this as sin 2x by 2. Now this is 2 by pi integral 0 to pi x into sin 2x by 2 dx. So after cancelling this, we have 1 by pi constant which is outside, 0 to pi x into sin 2x dx. Again we are going to use Bernoulli's formula. This is u and v. So u is x, v is sine 2x. So u dash is 1, u double dash is 0. So successive differentiation. This is successive integration. So v1 is minus cos 2x by 2 and v2 is minus sine 2x by 2 into 2, 4. And Bernoulli's formula is u v1 minus u dash v2 plus u double dash v3 dot dot dot. So now we have a1 equal to 1 by pi x into minus cos 2x by 2 minus 1 into minus sine 2x by 4 and u double dash is 0. So 0 to pi we have as a limit. When we substitute the upper limit, this is pi into cos to pi is 1 and we have minus here and sine to pi is 0. When I put the lower limit, everything is 0. And after cancelling this, we have only minus 1 by 2. So we got a1 as minus 1 by 2. So we are going to substitute all this thing in our f of x. Now f of x is a0 by 2. a0, what we got? 2. So a0 by 2 means 2 by 2. Then now I have to write a1 cos x. a1 is minus 1 by 2 into cos x I have to write. Since there is a minus sign, let's write straight away that minus sign alone instead of writing plus again. Then our summation starts from 2 to infinity because already we have written 1. an is minus 1 whole power n into 2 minus 1 whole power n into 2 by n square minus 1 into cos nx. Let's rearrange this further. F of x is equal to 1 minus 1 by 2 cos x and 2 can be taken outside the summation. So summation minus 1 whole power n by n square minus 1 cos nx and n is ranging from 2 till infinity. This is our required Fourier series half range cosine series for the given function f of x. Actually, there is a minus 2. So this is minus 2. So we keep the minus here. When we substitute here, and this will be, there will be a minus sign here, and that minus 2 is taken out. So even this is a minus sign. Thus we got the half range cosine series for the given function f of x. Now as the second part of the question, we should also prove this expression. So for proving this expression, we take our formula and in this we are going to substitute x as 0. So this will become f of 0 equal to 1 minus 1 by 2 into cos 0 is 1, then minus 2 summation n is from 2 to infinity. We have minus 1 whole power n by n square minus 1 into cos 0 is again 1. So now let's find f of 0. f of x is equal to x sin x. So in this case, if I find f of 0, it will be 0. So 0 equal to 1 minus 1 by 2 minus 2 and summation n is equal to 2 till infinity. We have minus 1 whole power n divided by this we split into n minus 1 into n plus 1. Now 1 minus 1 by 2 is 1 by 2. Then this entire term I can take to the other side. So this will become 2 times of summation n is from 2 to infinity minus 1 whole power n whole divided by n minus 1 into n plus 1. That is equal to 1 minus 1 by 2 is 1 by 2. Now we are going to take this 2 to the other side. So what happens? Summation n is equal to 2 to infinity minus 1 whole power n whole divided by n minus 1 into n plus 1 equal to 1 by 4. Now let's expand this one. So I have to start from 2 onwards. So minus 1 whole power 2 by 2 minus 1 into 2 plus 1. Then plus minus 1 whole power, next we have to put 3. So 3 minus 1 into 3 plus 1. Then minus 1 whole power 4 by 4 minus 1 into 4 plus 1. Like this, it's keep going dot 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 1 by 4. So now this will become 1 by 1 into 3. And this will become minus 1 by 2 into 4. So next will be plus 1 by 3 into 5 plus dot dot dot, we get 1 by 4. So this is the expression we are getting. But actually in the question they gave this expression. But as per this function, we are going to get only the expression which we derived and we are not getting this one. So maybe in the question they have given it wrong, and this is the correct expression which we supposed to prove for the given function f of x, which is x sin x in half range cosine series.